Hi, I'm Joseph Bautista and I'm going to talk about the RC passive filter for the mitigation of the harmonics in power system. First, I'm going to talk about what are the harmonics. Currently, in our homes, it is normal to have computers, TV, microwave, fluorescent tubes, etc. These are nonlinear charges that distortionate the current wave or voltage wave depending on the type of nonlinear load. The mathematician Jean-Baptiste Fourier determined that every non-sinusoidal continuous wave can be expressed as a sine wave with a fundamental frequency, plus a sine wave with a whole multiple of this, which is called harmonic. When performing an harmonic analysis, two things are taken into account: real-time analysis and frequency analysis, called spectra. Performing a real-time analysis, we can observe the peaks of the current or voltage wave. This graph represents a monophasic nonlinear charge, and this graph represents a triphasic nonlinear charge. If we perform a frequency analysis, we get a bar that shows us the percentage of the harmonic in our wave. For example, the monophasic charge, his most representative harmonic are the first one and the fifth one. In the triphasic charge, the most representative harmonic are the fifth one and the seventh one. Now I'm going to talk about the problems that cause the harmonics in our electrical networks. In the conductors, they cause heat by Joule effect and reduce the life utility. In the transformers, we have parasitic currents in the wiring that cause an overheating and decreasing of the performance. On capacitors, the harmonic wave causes a resonance with the electric systems, which effects are an increase of the voltage in this element. Although the laminar dielectrics designed for the capacitors allow high voltage, this produces a decrease of the service life and fatigue of the dielectric when overcharged for long periods of time, reduces the lifespan and the destruction of this electric element. Engines cause a parasitic current in the wiring. The greatest effects that voltage harmonics have on synchronous rotatory machines and induction motors is increase in the heat to the loss in iron and copper at a high frequency. The paired current, such as the 5th and 7th harmonic, have the potential to produce mechanical oscillation in the turbine generator combination or in the load system. This results that the torque oscillates caused by an interaction between the harmonic current and the fundamental frequency magnetic field. In the control measuring equipments, they cause wrong measures failure in the control process. These equipments are susceptible to incorrect operation due to the harmonics. In some cases, the most problems that have are the errors on equipment that take the zero step of the wave as a reference, and false positive and negative. Now I'm going to talk about the harmonics calculation. The effective value, which is the square root of the sum of the square of the current values. The individual harmonic distortion, which is a percentage that each of the harmonics has with respect to the fundamental current or voltage, and the total harmonic distortion. It's a ratio of the harmonic residual component divided for the fundamental component. Normative for harmonic in Ecuador. The ARCONEL is the Electricity Regulation and Control Agency in Ecuador, whose regulation determines that individual harmonic distortion and the distortion of the total demand. In this graph, we can observe the maximum limit of the harmonic voltage. Low voltage works in values less than 600 voltage. The medium voltage is greater than 600 and less of 40 kilovolts. The high group of voltage in group 1 works in greater than 40 kilovolts and less equal to 158 voltage kilovoltage, and in group number 2 we have greater than 188 kilovolts. To obtain the values for the pair harmonics, we have to multiply this 5%. And now, for the mitigation. If we want to mitigate or eliminate harmonics in our network, it is necessary to use rejection filters. These filters are composed of inductance and capacitor in series. In this way, we establish a tuning frequency from which we will reject the resonance phenomenon. The impedance behavior of a sentence is inductive, which means that higher frequency we have the impedance increase. By placing a rejection filter due to its low impedance, it generates a cutting frequency. From it, frequencies greater than the cut-off frequency, the harmonic current will see the battery as an inductance, so we reject the risk of resonance. Now we can have now in the market there are 3 types of passive RC filters. One is a tuned filter that only has one cut-off frequency. The compound passive filter that is formed of a capacitor and inductance in series, the parallel of an inductance, resistor, and capacitor. In here we can observe that has 2 cutoff frequency. In this we can observe that it is programmed in the 5th harmonic and the 7th harmonic. The cushioned filter, parallel of an inductance and a resistors in series with a capacitor. This is programmed for a 5th harmonic. We can observe that the impedance now has a limit. Other type of cushioned passive filters are formed by a capacitor and RC in series parallel with an inductor. This can be programmed for the 5th frequency, for the 5th harmonic. And thank you. Thanks for the attention.